going to demonstrate how to solve a simple transportation problem in Excel. For example purpose, I have taken a simple problem which has 3 sources and 4 destinations. Each source output or supply is given here, and each destination's demand is given here. These are the unit cost in dollars per truckload, or we can also call that we can also say that this is the cost matrix. Now once we have mathematically formulated the problem, I can use the Excel for optimizing it. Now what I'm gonna do here is I'm just gonna copy paste the same thing here, but instead of shipping cost, now I'm gonna write here decision variables, and I'm gonna delete these terms here, these numbers here. So what I'm going to do here is that I'm gonna make these as the decision variables. Okay, now why I'm doing that? Because I need to formulate the objective function. The objective function is 464 times the number of truckloads sent on this particular route plus 513 times number of truckloads sent on this particular route plus 654 times number of truckloads sent on this route. And that's why I can easily write the objective function as sum product of the cost and corresponding truckloads. And because how many truckloads to be sent on each route is my decision variable. Now after this, I can formulate the constraints. The first set of constraint is the supply side constraint, that whatever this source or cannery can supply to all these warehouses, 4 warehouses, it cannot exceed 75. So in order to facilitate that, what I'm gonna do is I'm just gonna shift it to one side, to the right, and here I'm just gonna write evaluated supply side constraint. Okay, this is supply side constraint, and that is nothing but sum of all. So this is essentially this is basically the mathematical formulation which I'm just transferring in form of Excel functions. And similarly here I'm just gonna drag it down, and I'm getting the supply side constraint, that summation of all the supply from one particular source cannot exceed, let's say, 100 here from this particular source. Similarly on the demand side, I need to put the demand side constraints. So here I'm just gonna write demand and whatever this warehouse one receives from all the sources or all the cannery, it cannot exceed 80. So for that I need to first of all find out how much this warehouse one is getting in general. This is the sum, and I'm just going to drag it. Now once the formulation has been formulated here, mathematical formulation has been formulated in the format of Excel, then I can use a solver. I'm gonna reset all. So the objective function is in cell I1. It has to be minimized, and the variable cells are these variable cells. The constraints are that since it's a balanced supply chain transportation problem, that means supply is equal to demand, I can use this particular set of constraint, that LHS is equal to RHS. Okay, so total supply is equal to left hand side of the supply is equal to right hand side of the supply here, supply side constraint. Some textbooks prefer to use less than or equal to, and similarly on the demand side, these numbers, okay, they should be equal to the actual demand what is required there, and hit OK. Sorry, and just hit OK. So simplex LP, and if you click on solve, it will give you the amount that needs to be transported on each route. If you want to look at the sensitivity analysis, you just click on sensitivity, hit OK, and it will appear here, and you can read the sensitivity report. So that's how you solve a simple transportation problem in Excel. Remember, for assignment problem also, you can use the same method, where you will have some cost matrix in any terms, and then you will have certain equivalent to supply side, equivalent to demand side constraints. You put it in this format, and similarly you can solve the assignment problem also. Thank you.